Good morning, ladies and gentlemen. I panicked a lot because I had some problems with my computer. And this is why it takes some time for me to fix the problem. Oh my God, I think it continues. Oh my God. No, something is really strange today. I hope that everyone can work normally. So I would like to ask you to think about some maybe problems which you tried, but they were tough and you like to ask me to help you. Let me grab a pen and I will be you right now. Just 1 second. Yes, I'm ready. I know that these problems I'm talking about proving identities can be tough, but I'm willing to help you with one problem of your choice right now. And you are, oops, oh my God. And I will be more than happy to help you with that problem. Guys, can you please reply to my question in the timely manner? Because we have so many things to do. Okay. Do you need my help?
Yeah.
Okay. I'm ready to help. You know what? I will start another material. If something comes to your mind after that, you will ask me. Unfortunately, I'm really in a hurry because of the technical problem today and other things. But I promise you to solve at least one more problem because I already solved many problems proving identities, but I do not mind solving another one. I'm starting section 3.5. Section 3.5 is in your textbook. On page number 218, you can look at this page. And sum and difference formulas. I'm going to first start with formulas. And again, the topic is sum and difference formulas. I would probably write sum and different formulas for trigonometric functions, definitely. And I will try to follow the same numerical order of formulas as you have in your textbook. So, first formula which you have in your textbook is cosine of alpha plus beta. And the second one is cosine of alpha minus beta. I'm going to write them one after another, and after that, I will show this to you. Sine of alpha plus beta, sine of alpha minus beta, and another set of formulas are for tangent. Definitely, we have in math other formulas for all trigonometric functions, not just for sine, cosine, and tangent. But your book has this because these are basic functions which you can find in all textbooks. But in some textbooks, you can find quite rarely, but you can find other formulas for cotangent, for secant, for cosine. Okay, I am starting. You can see the first formula which I wrote down is cosine alpha plus beta, and you can see the rest. And here, the symbol of that cosine in front of this parenthesis is not a number which we can distribute multiplying by everything what we have in parentheses, because unfortunately some people do not try to learn formulas and they think that they just can distribute that cosine symbol and use distributive property. It is not working here. It has much more complicated expansion. So it will be cosine of the first angle multiplied by cosine of the second angle. And this is also a catch in form of different signs on both sides. Look how this formula looks. Cosine of the sum of two angles alpha and beta equals to the difference of two products. One product has only cosines. The other product has only sines. Please be careful. Again, here, when we have a cosine of the sum of two angles, it is equal to the difference of two products. In each of these products, we have similar to each other functions. At the first place, it is cosine alpha by cosine beta. In the second product, it is sine alpha by sine beta. I'm going to, and this in your textbooks, is formula number 1. Formula number 1. Formula number 2 is also about cosine. And this is about cosine of the difference of two angles. How does it look? It has the same type of structure as we could observe in formula number 1, but cosine of the difference of two angles equals to the sum of two products. And this is again similar type of products as in formula number 1. Cosine multiplied by cosine, sine multiplied by sine, but cosine of a difference of two angles equals to the sum. Excuse me, I can see the sound here, which is quite interrupting. So cosine of alpha minus beta equals to cosine alpha times cosine beta plus sine alpha times sine beta. Okay, I'm going to show right now examples for these two formulas. This is why I will go directly to the exercise page. And this is, just 1 second, we have here many examples solved in this textbook, which is very good. And I am on page number 227, where we have the beginning of exercises, which is continued on page, exercises are being continued on page 228 and 229. So I'm going to show you how to use these examples. Let's see, I'm solving problem number 11. Let me write the page number. Page 227. Problem number 11. Sine of 5 pi over 12. Sine 5 pi over 12. Did you copy that problem?
Yes.
Okay. We do not know right away the value of sine of 5 pi over 12 because we learned values of sine, excuse me, let me write here also the formula for the sine, and I will continue. We do not know the value of sine of 5 pi over 12, and we need to do something to finally actually find some other way than just grabbing our calculators, entering sine of 5 pi over 12, and having the approximation, because here it says, find the exact value of each expression. Okay, what about breaking 5 pi over 12 into the, on the top, 5 pi, into the sum of two addends? 5 pi, is it actually, let's say, 3 pi plus 2 pi?
Yeah.
Yes.
Okay, this will be my first step. I am changing 5 pi to the sum of 3 pi and 2 pi.
Mm-hmm.
Next step, we did it many, many times. I'm going to separately divide 3 pi by 12 and 2 pi by 12. 3 pi over 12 plus 2 pi over 12 is replacing that original actually fraction which we had under symbol of sine. So which means sine of 5 pi over 12, we can rewrite as sine of 3 pi over 12 plus 2 pi over 12. But look precisely at each of these fractions. Maybe we can cancel reducing them, can we?
Yes.
Okay. 3 pi over 12. If we cancel by 3, is it pi over 4?
Mm-hmm.
2 pi over 12. Is it pi over 6?
Mm-hmm.
What about these two new angles which we have under symbol of the sine? Do they look familiar?
Yes.
Which means I can apply the formula, if I know that formula, of sine of the sum of two angles. This is why I'm going to write down formula number 3, expanding that because we need to know how to expand this expression. What about formula for the sine of alpha plus beta? This formula is not so confusing as formulas for cosine because if we have sine of the sum, it will be equal also to the sum of products. Yes, it will be equal to the sum of products, but I'm going to explain right now what we have here. Look at formula, look please at formula number 3. Formula number 3.
Yeah.
Sine of alpha plus beta equals to the sum of two products, and these products are mixed products. Now it is sine multiplied by cosine in both cases. First one, sine alpha times cosine beta plus cosine alpha times sine beta. You can see in the first product, you have sine alpha. In the second product, you have cosine of alpha. In the first product, you have cosine beta. In the second product, you have sine alpha. So you need to have different parts of these products. So in my case, what I have in this problem, my alpha is pi over 4, and my beta is pi over 6. You don't need to write this each time, but because it is the first example, I am showing this above that parenthesis. So which means expanding using formula number 3, formula number 3 is about sine of the sum of two angles. It will be sine of pi over 4 times cosine of pi over 6 plus cosine of pi over 4 times sine of pi over 6. This is what you are getting after you use formula number 3. Can you please write it down?
Can you lower it down a bit, please?
What?
Can you see better now?
Yeah.
Did you write it down?
Mhm.
Guys, do I have only one person?
Yes.
Yes. But now definitely we need to recall all these values which we learned long time ago. And let's start. Please try to participate. Sine of pi over 4 equals to what?
Square root of 2 over
Yes.
2.
Cosine of pi over 6 equals to what?
Square root of 3 over 2.
No, it is cosine of, yeah, for pi over 6, yes. Square root of 3 over 2. I heard something different. Okay, so square root of 3 over 2. And I already wrote it down. I will continue plus, what is the value of cosine of pi over 4?
Square root of 2 over 2.
Yeah, because sine and cosine for pi over 4, they have equal values. And sine of pi over 6 is
Half.
1/2. So which means we do not have any trigonometric symbols anymore. We just have sum of the product of numbers. Let's simplify. So square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4 plus square root of 2 times 1 is square root of 2, again over 4. And I definitely like to unite them in one piece for better looking answer. So it will be square root of 6 plus square root of 2 on the top, and you have square root of 6 plus square root of 2 over 4. I will show you different modifications of the same answer.
Okay.
Because we can write the same answer in slightly different forms. So I'm going to write, or it is 1/4 multiplied by square root of 6 plus square root of 2. Another form of the answer, because in your My Math Lab, you will see only one answer stored, which you have to choose from different versions of answers. And maybe it will be not the first version stored or the second, because I will show you the third one as well. So, and what about the third one? Square root of 6, is it square root of 2 times square root of 3?
Yes.
Yes. So in this case, in this parenthesis, you can, instead of square root of 6, have square root of 2 times square root of 3, and you can factor out square root of 2. So in this case, your answer has the third form, let's say, square root of 2 over 4, square root of 3 plus 1. And these are all legal answers. I can even box them so to make this more visual. This is all three here are correct answers. This is the case when you can have that answer which you like better if you are doing this on your paper and I need to grade your work. I will accept any of these answers because all three are legal. Unfortunately, in Pearson, in my math, only one answer is stored, and because of that, I cannot guarantee that it will accept all three versions. It will accept only that one, which actually was stored in their system. This is why if your answer is rejected, definitely it can be just completely wrong, but if you are absolutely sure it is correct, try to use one of these versions to see if system accept that answer or not. I'm going to show right now the problem with cosine. And this is problem number 13. Let me grab another piece of paper. Again, this is page 227. And problem number 13. This time it is cosine of 7 pi over 12. Cosine of 7 pi over 12. Okay. What can you recommend me to do with 7 pi? I would like to get your advice.
You can change it to 4 pi plus 3 pi over 12.
I think it is not a bad idea. Honestly, this is a really good advice. Let's try to do that. Thank you. And this is my first step. Instead of 7 pi, you can see on the top, I have 4 pi plus 3 pi. I'm going to break this into two separate pieces. Cosine of 4 pi over 12 plus 3 pi over 12. Can we reduce that fractions inside of parentheses?
Mm-hmm.
Yeah.
Can you help me, please, with new items? With new terms in parentheses? What should I write?
Cosine. Oh.
Yeah, cosine. I'm just talking about parentheses. Definitely you should start with cosine. But what do you have in parentheses?
Pi over 12 plus pi over 12.
One more time. I heard first is pi over 3 plus it should be
Pi over 4.
Yeah.
and what did we get instead of 3 pi over 12?
Pi over 4.
Right. Pi over 4. And now, should I apply formula number 1?
Yeah.
Yes.
Don't forget, it has an expanded form. It has a difference, not a sum. Please be very careful. So it will be cosine of pi over 3 times cosine of pi over 4 minus sine of pi over 3 times sine of pi over 4. And now, please recall all these values because we need to replace all these components products by their values. What is the value of cosine of pi over 3?
Half. Or 1/2.
One more time.
1/2.
Cosine of 60 degrees or cosine of pi over 3 equals to?
1/2.
I just wanted to hear more replies because I constantly hear just one voice. Times cosine of pi over 4.
Square root of 2/2.
Again, just one person.
Square root of 2/2.
Right, thank you. Now 2 voices. I would like to hear more replies. Sine of pi over 3.
Square root of 3/2.
Yeah. And sine of pi over 4.
Square root of 2/2.
Yes, I wrote it down. And now we need to multiply and simplify. So, and we can do this in exactly the same manner as we worked with the previous problem. So it will be square root of 2/4 minus square root of 6 also over 4. And you can have here also, ladies and gentlemen, I don't know who produces this sound. I constantly hear the strange sound and it is not really helpful. Can you please stop? So, and now you again can have here different versions of the answer. One answer is similar to what we had for number 1. So I'm going to box it right away. This is a legal form for the answer. Square root of 2 minus square root of 6 over 4. Or the second version, 1/4 times square root of 2 minus square root of 6. Second version, which I'm going to box as well, or another version, again, treating square root of 6 like square root of 2 times square root of 3, factoring out square root of 2, you can get the other version. And I'm going to box that as well. Square root of 2/4, 1 minus square root of 3. Okay. Not all the time formulas should be applied from left to right. Between left side and right side in these formulas, we have an equal sign, which means we can work using these formulas and from left to right, but we can use them from right to left. And now I'm going to solve one of these problems where we need to apply the formula from right to left. Let's say this is a problem from same page 227, and this problem is number 24. 24. What should we do here? Find the exact value of each expression, it says. Okay, I'm going to write it down, and after that, we will continue. 24 has sine of 20 degrees times cosine of 80 degrees minus cosine of 20 degrees times sine of 80 degrees. This is that problem. Consider the following thing. Let's say 20 degrees is alpha, 80 degrees is beta. In this case, what do we have? Listen carefully. In this case, we have sine of alpha times cosine of beta minus cosine of alpha times sine of beta. But we so far did not cover that formula, but it slightly reminds us formula number 3, right?
Yeah.
Yes.
Let's actually show what we have in formula number 4. Formula number 4 is sine of alpha minus beta. Let me expand this to you, and after that we will continue with that problem. This is what you have for number 4 formula. Sine of a difference, alpha and beta, so sine of alpha minus beta equals sine of alpha times cosine of beta minus cosine of alpha times sine of beta. It reminds a lot formula number 3, and here we have the same thing. On the left side we have sum, sine of the sum. On the right side we had in number 3 a sum of two products. In number 4 we have sine of the difference of two angles. On the right side we have a difference of two products. What about now problem number 24? You have right now 4 formulas in front of you. Which formula you think is the best choice for problem number 24?
Number
The
4.
fourth one.
Definitely number 4. Number 4 matches this problem, which we have in problem number 24. So this why, what I'm going to do, I'm going to replace that difference of two products by the sine of alpha minus beta, where alpha is 20 degrees angle and beta is 80 degrees angle. And look what I'm getting. I'm getting sine of 20 degrees minus 80 degrees, which equals to sine of negative 60 degrees. Negative 60 degrees. But I can apply another property of sine. Do we know that sine is one of odd functions?
Yes.
What can we do with this minus?
You take it to the front of the sign.
Take it to the front, move it to the front. So, and we are getting negative sine of 60 degrees. And now we need to replace sine of 60 degrees by its value and declare what we get as an answer. Please, can you help me?
Square root of 3/2.
Yes, and I also wrote it down. This is your answer. Can I please right now finish two other formulas, and not only, and there are two applications of these formulas. And after that, we will be able to solve any problem from this section.
Okay.
What kind of formulas am I talking about? Let me see what kind of numbers they have here in your 6 and 7. 6. I now I actually know. Today is really unusual day. It is just maybe, I don't know. I would like to ask other students, can you please tell me if you also hear that strange sound?
Yes, a little bit.
Yes.
I'm not.
Guys, unfortunately, if someone is accidentally producing this sound, can you be please respectful to the rest of the class? Because it is really difficult to provide lecture in that kind of condition. It is very loud. Can I please ask you to completely match if the section, because I really do not want to confuse you. Definitely this sequence of these formulas is replaceable. But let's change the number for sine of alpha plus beta for formula number 4. And for sine of alpha minus beta to formula number 5, because, excuse me?
Sorry, that was.
And because there are other formulas, 3a and 3b, which I'm planning to talk about. So because again, I like to completely match the numbers for formulas in your section, which probably can help you not to be confused if you decide to go over material in your textbook. So this what you have, formula number 1, 2, and after that formulas 4, 5, 6, and 7. I'm starting with formula number 6. Tangent of alpha plus beta. Tangent of alpha plus beta and tangent of alpha minus beta, they will be equal to fractions. Look what I did right after equal sign. I sketched quite long fractional line. What do you have on the top for formula number 6? You will have tangent of alpha plus tangent of beta. In formula number 7 on the top, you will have tangent alpha minus tangent beta. I did not complete formulas. I just wrote the top expressions. Now, you can see it also has tangent of the sum on the left. On the top, you have sum of 2 tangents. In number 7, you have tangent of the difference of 2 angles. On the right side, on the top, you have difference of 2 tangents. What about denominators? I'm going to write right now, and I will show it to you. This what you have. On the bottom of the formula number 6, you have 1 minus tangent alpha times tangent beta. In number 7, you have 1 plus tangent alpha times tangent beta. How can you memorize that formula? First, both equal to fractions. Both on the top have tangent alpha and tangent beta, but if you have tangent of alpha plus beta, as in formula 6, on the top, you have the sum of two tangents. On the top and on the bottom of each of these formulas, you have different signs. On the top, you have a sum. On the bottom, you have a difference in 6. If in number 7, you have a difference on the top with minus connecting pieces, on the bottom, you have 1 plus. So you cannot have plus on the top, plus on the bottom, or minus on the top, or minus on the bottom. If you have plus on the top, downstairs you will have minus. If you had minus on the top, downstairs you will have plus. These are formulas which we actually can talk about. Now I'm going to prove formulas number 3a and 3b, which are on page 220 in your textbook. I will be working with these formulas as I would work with exercises. Just consider this like additional examples. Okay, I'm starting. I'm starting with formula number 3a. What should we prove? You can treat this as proving identity, let's say, because it looks like an identity. What do we have here? Cosine of pi over 2 minus theta equals to sine theta. But I will go an extra mile and I will write same thing in degree form, because quite often you need to apply this formula with degrees in it. So it is same formula, only instead of pi over 2, I wrote 90 degrees. So cosine of 90 degrees minus theta is equal to sine theta. Did you have an opportunity to write it down?
Yes.
Okay. I'm starting my proof. I'm starting with the left side. Left side. What do you see on the left side? It is cosine of pi over 2 minus theta. Which of these formulas which we just talked about today, 1, 2, 4, 5, 6, or 7, can be applied?
The second one.
Second one, absolutely correct. Can we treat here pi over 2 like alpha and theta like beta?
Yes.
So, which means cosine alpha, it will be cosine of pi over 2 times cosine of beta, which is cosine theta, with cosine of the difference we have on the other side a sum, which means I am placing plus, and I will continue with what? Sine of alpha, which is sine of pi over 2, because alpha is pi over 2, times sine of beta, which is sine of theta. Please write it down. And now let's simplify. Cosine of pi over 2, is it 0?
Yes.
Yes.
Sine over 2, is it 1?
Yes.
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 And look what we have. 0, oops, 0 times cosine theta plus 1 times sine theta, 0 times cosine theta. Is it 0?
Yes.
Sine theta times 1, is it just sine theta?
Yes.
Are we done with proving?
Yes.
Look, and I put that square field, square, which means the end of proof. We proved that. So which means yes, this is a working correct formula. But let me tell you about really important detail about this formula. I don't know if you took geometry course or not, but how we call these angles is really important. So even if you did not have an opportunity to take geometry course, let me tell you about this definition. If two angles in the measure give us 90 degrees, we call these angles complementary. In other words, complementary angles are angles which in the sum of their measures give us 90 degrees. If you did not know about that, can you please write it down? It is really important. So you can write down that alpha and beta are complementary angles if alpha plus beta equals 90 degrees. Alpha and beta are complementary angles, then alpha plus beta equals 90 degrees. And look what we have here. What if we have, let's say, cosine of 30 degrees? What would be complementary angle for 30 degrees, ladies and gentlemen? Which angle added to 30 degrees will give us in the sum 90 degrees?
60 degrees.
Is it 60 degrees?
Yes.
So can I say that 30 degrees and 60 degrees angles are complementary?
Mm-hmm.
Yes.
And look what I can write here. Cosine of 30 degrees equals to sine of 60 degrees. And I will prove why. Cosine of 30 degrees. Can I treat that it is cosine of 90 degrees minus 60 degrees? Guys,
Yes.
Yes.
is it matching that formula 3a, which says cosine of 90 degrees minus theta equals sine of theta?
Yes.
Which one is my theta? My theta is 60 degrees angle. So which means it will be equal to sine of that theta, and sine of theta is sine of 60 degrees. I started with cosine of 30 degrees here and ended up with sine of 60, which we just previously announced. This how I easily can prove it using that formula 3a. Now I'm going to prove formula number 3b. In 3b, we have similar thing, only with sine instead of cosine. And we need to prove that sine of pi over 2 minus theta equals to cosine theta. Or again, I can write this with degrees. Sine of 90 degrees minus theta equals cosine theta. And I'm going to prove it. And after that, we will have a break and we'll continue after the break later. So I'm starting with the left side. I'm writing down sine of pi over 2 minus theta. Which formula can I use to expand this? 1, 2, 3, or 1, 2, 4, 5, 6, 7. Which one?
Sine alpha minus beta.
Is it number 5?
Yes.
Right. Instead of alpha, we will be using pi over 2 again. Instead of beta, we are going to use theta. So it will be sine of pi over 2 times cosine theta minus cosine of pi over 2 times sine of theta. So this is your first step in proof.
Mm-hmm.
Again, sine of pi over 2, is it 1?
Yes.
Cosine of pi over 2, is it 0?
Yep.
So 1 times cosine theta, it will be cosine theta. 0 times sine theta is 0, so I'm going to ignore it. So which means actually I already proved that, and I am placing another small square because I definitely proved that formula. What I'm going to do right now before the break, I will call your names. I was so stressed out by not working properly computer in the morning, so I panicked. So this is why I wanted to start working with problems as soon as possible. Okay, today is 28. So Bryce?
Here.
Gracia? Gracia? Alexia?
Here.
Hannah?
Here.
Demeter?
Here.
Benjamin? Jesus?
Here.
Ariana?
Here.
Desiree?
Here.
Lila?
Here.
Bhaktima?
Here.
Jessica? Jessica? Ivona?
Here.
Devin?
Here.
Valeria? Valeria? Okay, guys.
Here. Here.
Yeah, okay. You can come back. Let me actually check. Okay, right now it is 11:14. It's okay. You can pretend that it is already 11:15. So at 11:20, we will continue our class. Okay?
Okay.
So, okay.
Excuse me?
I am back. Can I continue, please?
Okay.
Yes.
Yeah.
So far, right now, we actually covered all formulas which are in this section. I need to warn everyone that with each new section after that, we will be getting new formulas. So please be very serious about these formulas, because usually in the normal settings, I offer people pop quizzes for formulas, because you need to know that formulas for upper level of classes if you are planning to take next levels. So what I'm going to do right now, I will be randomly grabbing problems from this section and working to the end of today's class. So I'm going back to page number 27, and I will choose some problems from that section, and we will be working together with these problems. Okay. Again, if any problem catches your attention, feel absolutely comfortable to ask for that particular problem. Are you okay with problem number 30?
Yes.
Is it just one person's opinion?
Yes.
Yes.
Okay. So number 30. Number 30 has cosine of 5 pi over 12 multiplied by cosine of 7 pi over 12 minus sine of 5 pi over 12 times sine of 7 pi over 12. Cosine 5 pi over 12 times cosine 7 pi over 12 minus sine of 5 pi over 12 times sine 7 pi over 12. What do we see here? Do we have here two products?
Yes.
Can you see that in these two products, these are sine multiplied by sine and cosine multiplied by cosine?
Yeah.
Do you see that in both products, we have same angles, which are 5 pi over 12 and 7 pi over 12?
Mm-hmm.
Yes.
Can I say that actually this is cosine alpha times cosine of beta minus sine of alpha times sine of beta?
Mm-hmm.
Yes.
Does it remind you any of today's formulas?
Yes.
Yes.
Plus beta.
Is it number 1?
Mm-hmm.
Let's apply it. So which means instead of this quite long expression, Can we just simply write that it will be cosine, parenthesis, alpha plus beta, where alpha is 5 pi over 12, and beta is 7 pi over 12. So we replaced this quite long expression by much shorter one, where you have cosine, and in parentheses, you can see the sum of both angles, right?
Yeah.
Let's simplify. Look, inside of this parenthesis, you have two fractions. Do they carry same denominators?
Yes.
Should we, adding these fractions, keep the same denominator?
Yep.
And add tops?
Yes.
If you add 5 pi and 7 pi, what do you get?
12 pi.
Is it 12 pi on the top?
Yep.
So finally, is it cosine of 12 pi over 12? Can we cancel both 12?
Yeah.
What are we left with?
Pi.
Cosine pi.
Cosine of pi. But is it our old value?
No.
What it is equal to?
-1.
-1, definitely. Voila. This is a very simple answer. -1. And you need to work with all these problems from 23 to 32 in the same way, because it is not the only problem which I solved. It is already the second problem from this small spot. And what do you see here? We precisely look at the formula to look at how it's structured. If we discover that it is, let's say, sine of certain angle or multiplied by cosine plus or minus now cosine of the first angle multiplied by sine of the second, it means it can be formula or number 4 or number 5. It depends on what kind of sign you have connecting these products. So if they are connected by plus, it will be sine of the alpha plus beta formula. If it is the case when products are connected by minus, it is matching formula number 5 for sine of the difference of alpha and beta. If you have in your products cosine by cosine and sine by sine, definitely it can be or formula number 1 or formula number 2. I solved problem number 24 where we applied formula for the sine. I solved problem number 30 where we applied formula for cosine, but the method is the same. With your permission, can I move to another spot?
Okay.
Yeah.
Okay. And let's see what we should do here. This is a big problem because it has A, B, C, and D. So I am going to grab one of these problems because all others are very typical, very close to what we had. Is it okay if I choose number, let's say 34?
Okay.
Yep.
Okay. I'm writing down number 34. Again, same page, 227. What do I have here? Find the exact value of each of the following under the given conditions. What kind of conditions? Cosine alpha equals square root of 5 over 5. And alpha is between 0 and pi over 2, which actually means that alpha belongs to the first quadrant. Sine of beta equals -4/5, where beta is between negative pi over 2 and 0. Ladies and gentlemen, if your angle is between negative pi over 2 and 0, can you please identify the quadrant for that angle?
Quadrant 1.
No,
Oh,
it is between negative pi over 2 and 0.
quadrant number 4.
Definitely. This what I actually wrote down. And now let's see what we need to find. Part A, they are asking us to find sine of alpha plus beta. What I'm going to do, I will immediately expand this using the formula, which is formula number 4. Sine alpha times cosine beta plus cosine alpha times sine beta. I expanded this using that formula. And after that, I will see which parts I have and which parts I need to find the values for. So I'm going to underline that parts which are given. Cosine alpha is given, sine beta is given, and I will place question marks above that items which I do not know values for. You can see what I did. So which means with the given conditions, I need to find sine alpha and cosine beta. I'm starting with alpha, sine alpha. So can I write actually making this a little bit shorter as a solution that sine square alpha equals 1 minus cosine square alpha? Can I?
Mm-hmm.
Guys, is it everyone's opinion?
Yes.
Yes.
And now I will continue because sine square alpha will be equal 1 minus cosine alpha itself is equal to square root of 5 over 5. But I need to square it. If I square root of 5, it will be 5. If I square 5, it will be 25. So 1 minus 5/25. 1 is 25 over 25. So it will be 20/25. Is it correct?
Yes.
And I purposely decided not to reduce that because I will be taking square root number. This is why I prefer to have 25 in the denominator. So now, sine alpha with square equal to 20 over 25, but I remember that alpha belongs to the first quadrant. In the first quadrant, sine is positive or negative?
Positive.
Positive.
Yes.
So which means sine alpha will be equal to positive square root of 20 over 25. And it means that sine alpha is equal to the fraction. Downstairs we have 5. Square root of 20. 20, is it 4 times 5?
Yes.
If you take square root of 4, is it 2?
Yes.
Look what I'm getting. Sine is equal to 2 square root of 5 over 5. And I found that value. Excellent. Now I'm just going to plug these numbers. Sine alpha plus beta equals to what? Sine alpha, it is 2 square root of 5 over 5. But I do not know cosine's beta value. I need to find it. Let's find that value as well. So it will be From the beta will be from the fourth quadrant. By the way, in the fourth quadrant, cosine is positive or negative?
Positive.
Positive. Can I write that cosine square beta equals 1 minus sine square beta?
Yes.
Yes.
It is also coming from the formula that sine square alpha plus cosine square alpha equal to 1. I'm going to plug the value instead of sine, but I need to square it. Sine was negative, which is correct. In the fourth quadrant, sine is negative all the time. But negative squared, is it positive?
Yeah.
So if you square negative 4/5, is it positive 16/25? One minus 16/25. 1 is 25 over 25. 25 minus 16, is it 9?
Yes.
So we are getting that cosine squared equals 9/25. But I don't need cosine squared. And again, we already talked about that in the fourth quadrant, cosine is positive. So cosine beta equals square root of 9/25 positive square root. So what it is equal to? 3/5. This is your cosine value, 3/5. This why now I don't have any missing part. So I already wrote sine of alpha plus beta equals 2 square root of 5 times 5, and I'm going to continue that. So it times cosine of beta, which is 3/5, plus cosine alpha. Cosine alpha was given in the problem, square root of 5 over 5. And sine beta also was given. It is negative 4/5. I just plugged all these numbers now. And now I'm just going to multiply, add, subtract, everything what I need to do. So equals 2 square root of 5 times 3 is 6 square root of 5. Downstairs I have 25. Positive times negative is negative. And it will be 4 square root of 5 over 25. These two fractions carry the same denominator. I will keep same 25 downstairs. 6 square root of root minus 4 of same roots is 2 square root of 5. And this is your exact value. I am done. I am done with this part A. I found that to find this result, I was forced to find missing values, and I probably in the next problem, it will be a little bit shorter because I already have values of important items. So now, can I move to part B?
Yeah.
What should I find in part B? Cosine of alpha plus beta. My first step here, I will expand this formula. Is it formula number 1?
Yes.
So apply it. Write it down in its expanded form, which I did. And now analyze all these components to see if you are missing anything. Do we know cosine alpha value and cosine beta? Guys, do we know already these values?
Yes.
Yes. Do we know values of sine alpha and sine beta?
Yes.
Does it mean that we are not missing anything?
No.
Right? Plug the numbers. cosine alpha square root of 5 over 5 times cosine beta. Cosine beta we found it is 3/5 minus sine alpha. Sine alpha we found in the process, and the value was 2 square root of 5 over 5. Sine beta was given in the problem. It is negative 4/5. Plug these numbers. And now, continue. 3 square root of 5 over 25 minus in front, minus in parentheses, it will be plus 4 times 2 square root of 5, 8 square root of 5 over 25. These two fractions carry same denominators. I'm copying 25, adding the top parts, 11 square root of 5. Voila. This time I found this answer much faster. Can I move, with your permission, to the next part?
Yeah.
Yep.
Which is part C. And I need to find sine alpha minus beta. If you look at formulas, you can see that it is actually formula number 5. I'm going to expand right now this formula. It is sine alpha times cosine beta minus cosine alpha times sine beta. This is my first step in the process. Now I am looking at each of components. These are sine alpha and cosine beta, and I know values for both, and cosine alpha and sine beta, and I know values of these two as well. So just plug everything in. So what do you have? First one, sine alpha. Sine alpha we found earlier, 2 square root of 5 over 5. Cosine beta, we also found, it is 3/5 minus cosine alpha was given in the problem, and sine beta also was given in the problem. I plug these numbers, and now I'm going to multiply. Multiplying first two, I'm getting 6 square root of 5 over 25 plus, multiplying seconds, it will be plus 4 square root of 5 over 25. And both fractions have same denominator. This y, I have 25 in denominator, 4 square root of 5 plus 6, it is 10 square root of 5, but it is not my final answer because I can reduce this fraction. 10 divided by 5 is 2, 5 divided by 5 is 5, and voila, this is my answer. This is my answer right here.
Mm-hmm.
Did it click for you, ladies and gentlemen?
Yes.
Yeah.
Good. Can I move to the last part, which is D?
Yes.
Okay. D. You can see this is quite a long problem because it has A, B, A through D questions. So what should I find here? Tangent of alpha minus beta. This time it is tangent of the difference. And in the list of formulas, it is formula number 7. I'm going to expand this according to this formula. It should equal to tangent alpha minus tangent beta over 1 plus tangent alpha times tangent beta. And now I don't have these parts. What should I do? I need to find tangent alpha and tangent beta. But knowing sine and cosine, I can immediately write that tangent alpha is sine alpha over cosine alpha, as we know. If you agree with me, please verify that. Yes?
I agree.
Yes.
Plug your numbers. So sine alpha, where are you? Right here. It is 2 square root of 5 over 5. Cosine alpha is square root of 5 over 5. So I will convert this into multiplication by the reciprocal. And this is what I'm getting. Can you see?
Mm-hmm.
Can we cancel?
Yes.
Yes. Yes, we can. First 5's go away and square root of 5 on the top and the bottom. And we are left with extremely attractive value of tangent. Tangent is equal to 2.
Yep.
In the same absolutely manner, I will find tangent beta. Now using formula, only difference is instead of alpha, I will be using now beta angle. So tangent beta equals, okay, where is my sine beta? Sine beta was negative 4/5. What about cosine beta? We found it. It is 3/5. Do we know that positive, negative over positive will be negative?
Mm-hmm.
4/5 times 5/3. And we cancel 5's. Can you see that on the screen?
Can you move up a little bit on the other side?
You put it in number 6.
Can you see now?
Yes.
So, and what would be the value here? Is it negative 4/3?
Yep.
So now, one tangent is equal to 2, the second is equal to negative 4/3. Please continue. So it will be tangent of alpha, which is 2, minus, okay, parenthesis, negative 4/3 over 1 plus tangent alpha is 2 times tangent of beta, parenthesis, negative 4/3. This is what you are getting. And let's simplify that using simple arithmetics. So it will be on the top 2 plus 4/3. On the bottom, it will be 1 plus 2 times negative, it will be minus 8/3 equals, what about the top? If you have 2 plus 4/3, 4/3, is it 1 and 1/3?
Yes.
If you add 2 and 1 and 1/3, is it 3 and 1/3?
Yes.
On the bottom, 1 minus 8/3. 1. Is it 3/3?
Yes.
Yep.
So, which means it will be 3/3 minus 8/3. Is it negative 5/3?
Yep.
Yes.
Positive divided by negative. Is it negative?
Yeah.
3 and 1/3. Is it 10/3?
Yes.
Yeah.
Is it negative 10/3 times 3/5?
Yeah.
Can we cancel?
Yep.
3 and 3 are gone. 5 and 10 can be reduced. And what do you have, guys?
2.
What is your
Negative.
answer?
-2.
Absolutely, yes. And we are completely done with this problem. What am I planning to do the next time? I will finish definitely next time that section and we'll start another section. I will be working with identities and equations. Is it clear to everyone?
Yeah.
Basically, this material from 228 and 229, but I will not be forced to prove formulas for that particular section anymore. So I will just quickly solve this type of problems. And I think we will, in the second part of next lecture, we will be able to start another section.
Okay.
I really apologize again for technical delay today a little bit. It was few minutes, but I really panicked badly because unfortunately I had a technical problem. We depend now on these devices. And I hope it would be not a problem the next time. With your permission, can I finish my lecture today?
Yeah.
Yeah.
One more time,
Okay.
only, I called the name of the person. Jessica, are you here? No. Okay. So thank you, and dear ladies and gentlemen, have a nice, beautiful day. Okay?
Okay.
Goodbye.
Bye. See you.
Bye.
Thank you.